Well, hello there. I just finished up a little bit of studying. Today the Newtonians will present Newton's 3 laws of motion and action. You don't know what they are? Follow me.
For this experiment, we will be applying Newton's 3 laws to bowling. We will be using a tennis ball, basketball,
and water bottles.
Newton's first law is that every object continues in a state of rest unless acted on by a non-zero net force. According to the first law, water bottles and a basketball are in a state of rest before there is no force. As you can see, if I put a force on the ball and water bottles by pushing the ball rolls and the water bottles leave state of rest.
In Newton's first law of motion, it also states that an object will continue moving in a constant speed and a straight line unless acted on by a non-zero net force. As I roll the ball will roll at a constant speed and in a straight line. The ball will only be stopped by an outside force. If we didn't have friction force, air resistance, and an outside force acting on the object will continue on a straight path at a constant speed forever.
Newton's second law states that the acceleration of an object is dependent on the net force acting upon the object and the mass of that particular object. Take into consideration that the acceleration of the object is always in the direction of the net force. As the force acting upon an object is increased, the acceleration of the object is increased. On the other hand, as the mass of an object is increased, the acceleration is decreased. Force and acceleration are proportional. Mass and acceleration are inversely proportional. This law is applicable to our experiment because, as you can see, when I roll a basketball with a given force, the basketball decelerates due to its increased mass in comparison to the tennis ball that will be presented shortly. The force applied to the basketball will be in the same direction as the acceleration of the basketball. As stated in the second law, if the mass of an object is decreased and given the same force, the acceleration should increase. Let's test Newton's second law and see if it is true. The force applied to the tennis ball and basketball are the same. Since the mass of the tennis ball is 11 times smaller than the basketball, the tennis ball will accelerate 11 times greater than the basketball. The factor was approximated from the mass of the tennis ball, around 57 grams, in comparison to the basketball, around 620 grams. As you can tell, when I apply the same force upon the basketball and the tennis ball, because the tennis ball had a smaller mass, it accelerated faster than the basketball approaching the pins.
Newton's third law states that when an object exerts a force on another object, the second object will exert an equal and opposite force on the first. In this picture, the arrows pointing in opposite directions indicate the equal forces the objects are exerting on one another. As the basketball exerts a force on the water bottle reacts by exerting a force on the basketball. In this case, the action force is the basketball on the water bottle, and the reaction force is the water bottle on the basketball.